Welcome back to All This Math. This is Professor Parker. Please make sure you're subscribed to the All This Math YouTube channel. Go ahead and drop a comment down below or a question. Drop a question down below if you got a question about the channel, about the content we have on the channel. Also, if you have a question about this example that I'm about to explain, which deals with probability. All right. Also, share the video with somebody and please hit the like button. All right. Also, I'm going to give a shout out to Cheney University. I'm not an alum of Cheney University, but I have been an educator at Cheney University since 2019. So we're going on 6 years now. Well, I'm in my sixth year now of being an educator at Cheney University, teaching math courses such as math methods, where I teach the new math that a lot of people complain about, right? Common Core math. I've also taught an algebra course at some point, like during the pandemic. I taught an elementary algebra course. But a little bit of history about Cheney University. Started out as the Institute for Colored Youth, right? In 1837 was when it was founded. It was in South Philly, not too far from Broad and South, like Ninth and Bainbridge or somewhere around there before relocating out to about an hour outside of Philadelphia. I think it's either in Delaware County or Chester County. I should know that. Unfortunately, I don't. But some serious people. I think Fannie Jackson Coppin was the principal of Cheney, well, of the Institute for Colored Youth many years ago. At the same time, a brother named Octavius Cato was a math teacher there, a math instructor there. He also was a baseball player, civil rights activist, human rights activist, shared stages with Frederick Douglass, helped to recruit brothers into the Union Army back in the 19th century in Philadelphia, right? Um, and also just and again, I was highly motivated to one of the reasons I was highly motivated to go out there and teach is because of learning about people like Octavius Cato and me wanted to carry on that tradition of black men teaching math, getting busy and teaching math and providing that to future generations. So yeah, so that's a little bit about Cheney University, but of course go do your research, go do your own research on Cheney and other historically black colleges. All right, now that we got that out the way, let's talk about this probability question. All right, this probability question. Now, of course, it's a little word problem. Don't get intimidated by word problems. And this comes from the HSPT math playlist. HSPT stands for the High School Placement Test, which is a test in which is a test of eighth graders. Right, eighth graders take this test when they attend Catholic or parochial schools. All right, and it's meant to test their mathematical ability in terms of and also to predict or forecast how they will perform on a high school level in math courses. All right, and this is the type of question that you might see on that exam. But at the end of the day, it's a probability question. So even if you don't attend a private school, a parochial school, or a Catholic school, you still need to be responsible for knowing this type of information because probabilities are important. Understanding that as a concept is very important. So let's read the question. It says a bag has 3 red marbles. I try to color code this, you know what I'm saying? So I tried to get a little fancy with it. 3 red marbles, 5 blue marbles, and 4 green marbles. What is the probability of choosing a non-green marble? All right, non-green marble. So probability non-green. All right, so meaning something that's not green. So if it's 3 colors, one of them is green. What's the other 2 colors? Red and blue. So really, we asking what's the probability of choosing a red or blue marble? All right. So first, let me set it up. Right. So you write the capital P, which stands for probability, and then you write non-green. So probability of non-green is equal to the probability of a red or blue. Now, in probability questions, again, math is a language. So we have to know how to read the language of math and also speak the language of math. When we use the word or in probability, which is a branch of mathematics, along with statistics, the word or means addition or it indicates addition. Usually the word and indicates addition, but in probability, and indicates multiplication. And I'm sure it still represents addition because multiplication is just repeated addition anyway, right? But when you see the word or in a probability question, that means we're going to add a couple things together. So probability of a non-green is equal to the probability of a red or the probability of a blue. Non-green, meaning it ain't green. If it ain't green, it's got to be red or blue. All right. Now, what's that going to be? Probability of red plus, because with the word or, The word or indicates we do an addition. All right. So probability of red plus the probability of blue. Now, how do we represent the probability of pulling a red marble? All right. So probability is usually represented in terms of a fraction. So we need to understand fractions as a concept in order for this problem to make sense. So the first thing we need is our denominator. Let's start with our denominator. Let's work from the bottom up, right? Just like how some people get dressed. They pick out a pair of sneaks they want to wear first, or a pair of shoes they want to wear first, and then they pick an outfit after that. Pick their jeans and their shirt, whatever, maybe a hat, some other accessories, right? Bottom up, right? So denominator first, denominator's on the bottom. So what is our denominator going to be? Our denominator for the probability of pulling a red marble is going to be the total number of marbles. The total number of marbles, right? So we got 3 red plus 5 blue. That's 8 plus 4 green. That's 12. So in that bag is 12 marbles altogether. So that's our denominator. It's 12 marbles altogether. So we got 12 for our denominator, not our numerator. Our numerator is going to be the number of red marbles. So the number of red marbles is 3, right? So that means we got 3 chances of pulling out a red marble because it's only 3 red marbles in it. We can't. It's not going to be 4 out of 12 because it ain't 4 red marbles. It's only 3, right? It's not going to be 2 out of 12 because it's more than 2 red marbles. It's 3 of them. All right. So we're going to put the 3 for our numerator. Then we put our plus sign, bring that down. Now we do the same thing for the probability of pulling out a blue marble. Again, what is the total number of marbles in the bag? 12. It's still 12. That don't change, right? So we got fractions with common denominators already. All right. And then how many blue marbles is it? It's 5. All right. So now we're going to add them up. So we got 3 twelfths plus 5 twelfths. Altogether, how many twelfths do we have? We got 8 twelfths. So we got 8 twelfths. And then we want to reduce that. How do I know I can reduce? This is a fundamental concept from mathematics. How do I know I can reduce? If you look at your numerator and denominator, if your numerator and denominator have a common factor that is not 1, a common factor, again, that is not the number 1, that means you can reduce it, right? Meaning you can make these numbers smaller. So 8 and 12 have a common factor of 2, but I wouldn't use 2. Why not? Why wouldn't I use 2? Because if I use 2, I'm going to break this down into 4 6. I'm going to still have to reduce it again. If you use 4, 8 and 12 have a common factor of 4. That's the greatest common factor, what we call the GCF, greatest common factor. Some people call it HCF, the highest common factor. HCF, GCF, whichever one you like, right? Then we only got to do the step 1 time. So it's up to you. If you want to do the step twice, go ahead. Divide each of these by 2. You're going to get 4 6. Then divide each of those by 2 again. You're going to have to do the step 2 times. That's not a problem. If you want to do that way, cool. I'd rather do it in 1 step. But I also want you to see the difference, right? So that's why I'm talking about it, because I want you to see the difference. Because a teacher might say, well, you should always use the GCF, and then they'll tell you why. And then I'm like, well, you don't got to always use the GCF, but just know what you're doing. This is my one of my mantras in life. Do what you want, but know what you're doing. Think about that. Do what you want, but know what you're doing. So if you want to use 2, go ahead. But just know you're going to have to do the step over again. But if you use the greatest common factor, GCF, or the highest common factor, HCF, then you only going to have to do the step 1 time. So 8 divided by 4 is 2. 12 divided by 4 is 3. Make sure you know your division facts by heart from memory, right? You shouldn't be thinking, oh, and you don't need to use a calculator to do 8 divided by 4, hopefully. If you need a calculator right now to do 8 divided by 4, I hope that you decide for yourself so that you can live better, to memorize some division facts so that eventually you will not have to use a calculator to do 8 divided by 4 or 12 divided by 4, right? So this is our answer, 2/3. So there's a 2/3 chance of choosing a non-green marble. Or we could say a 67% chance. A 67% chance or a 2 out of 3 chance of picking a marble that's not green. Not green. So a red or a blue. All right. That's how you do a probability question. All right. Now, once again, make sure you subscribe to the channel if you're not already. Please like the video. If there's something I explained up here that you don't fully understand, please put your question in the comments. Put your question in the comments or put a comment in the comments. All right. Also share the video with somebody else. And once again, shout out to Cheney University. I've been teaching there since 2019. And shout out to all the HBCUs, right? Do your research on Cheney, other HBCUs, and I'll see y'all in the next video. Peace.